Science!
Hey guys, welcome to Science This Week. So this week, I was out of town on a very special science mission, actually, that we will be talking about on a future science episode. But because I was out of town, I didn't get a chance to record a normal science segment for this week. So in lieu of that, we're going to replay one of my favorite science segments we've done on this show. And that was when we had theoretical physicist Dr. Michio Kaku on this show. Not only did we have him as an interview, but we also involved him in the science segment that week. And it was so much fun to talk to him because recently, at that time, there was new information about exoplanets, and which leads always to the question of, is there life in the universe? And to be able to ask those questions of Michio Kaku was a dream come true for someone like me. So we got to do that. Dustin and I got to sit with him on the phone and ask him real questions about life in the universe, what it would take to find it, and what it really means when we're finding these new exoplanets. And that's going to be the replay from this for this week's science segment. And as a bonus from that episode, I also involved a big fan of science and Michio Kaku, Bill Farmer, the voice of Disney's Goofy, who was also a guest on this show, but this was before he was ever a guest. We had him record 2 questions for Michio because he's such a big fan of his, and Michio answered his questions back. So as a bonus, I'm going to put that in this week's science segment as well. So this week, actually, there's been some recent discoveries from the K2 mission from NASA's Kepler Space Telescope. And in an upcoming article in the Astronomical Journal, they are talking about how they've found 95 new extrasolar planets, which I think is incredible. And this also harkens back to in 2016 when we discovered the TRAPPIST-1 system with 7 different exoplanets. And now the Hubble telescope is giving us a heck of a lot more information observing the planet's atmospheres and water compositions, and with some having the potential to hold even more water than Earth. And first, I would love for you to explain to us and our listeners, what is the difference between an extrasolar planet and an exoplanet?
Well, an extrasolar planet is just a planet outside our solar system.
Okay.
Because it's extrasolar. Solar implies our solar system. And an exoplanet is just anything out there.
Okay.
But basically, they're interchangeable.
I see. How close do you think we are to discovering planets with a habitable atmosphere?
I wouldn't be surprised whether next year or the year after that we find a doppelganger in outer space. That is, a planet that has roughly the same size as the planet Earth and potentially has liquid oceans out of which DNA could be formed. Now, right now, we have found roughly 20 or so super-Earths, planets that are, for example, 50%, 100% bigger than the Earth. But I think we're getting very close now to finding a twin of the Earth in outer space that is the same size of the Earth and potentially could have liquid water oceans.
Wow. Yeah, I mean, that begs the question, and I know you've been asked this before, but do you believe there is intelligent life in the universe?
Well, I think we have a census now of the Milky Way galaxy that, on average, every star has a planet going around it, mainly Jupiter-sized, but about maybe 1 in 20 of them, who knows for sure, but about 1 in 20 of them in turn have Earth-sized planets going around. And if you do the math, we're talking about billions of Earth-sized planets in our own backyard. So the probability that we could have microbial life and even intelligent life is extremely high just within our own backyard.
Wow. That's crazy. I mean, speaking of, in our backyard, what about Mars? When we eventually get there and we start really surveying and digging around the planet, do you think we will eventually find evidence of life, intelligent life, or maybe, something that was there before?
Well, there are several places that we have not explored on Mars. We've been on the surface of Mars, basically in areas that are quite flat, because we don't want the space probe to tip over and crash. We have not been to the polar ice caps. We have not been underground. We have not been to, for example, the Grand Canyon of Mars, which is Mariner Valley. And so there are large portions of Mars that we have not visited at all. So there's always a chance that microbial life could exist. We do find methane gas coming out of the planet. There's a debate as to whether or not the methane gas is organic or not, or natural. But we cannot rule out the possibility that there's some kind of microbial life on the ice caps or maybe underground. Like, where did the water go on Mars billions of years ago? It went into outer space, it went into the polar ice caps, and went into underground permafrost. So if there was intelligent life, they would follow the water. They would go to the ice caps, they would drill underground, and they would flee into outer space. They would follow the water.
Wow. And that just begs the question, if and when we do find intelligent life in the universe, whether it be, light years away or in our own backyard, what do you think the first steps that humanity should take when and if that happens? Obviously, I always think of Hitchhiker's Guide to the Galaxy. Don't panic. Obviously, let's hope none of us panic. But what should our first steps be when that discovery is made?
Well, first of all, there are no protocols that you see often in the movies where the Joint Chiefs of Staff get together and tell the public don't panic or keep everything a secret, right?
Right.
There are no such protocols, okay? Governments have not come together to discuss this. So I think, first of all, we'll probably pick up a radio signal from a nearby planet, and the first response will be to decipher the message. The message will be regular rather than random, indicating that there's an intelligence behind it. And we'll have to use supercomputers to decipher it, okay? Mm-hmm. At that point, it's going to leak out. People cannot keep secrets. It'll leak out that we've detected an intelligence signal from outer space. First, we have to translate it. Second, we have to then figure out the level of technology. Are they vastly superior to us, or are they just beginning to understand radio, for example, like our civilization? In other words, are they type 1, type 2, or type 3? We'll have to figure out which type civilization they are. Type 1 is planetary. They control the weather. They control all planetary forces. Type 2 is stellar, like Star Trek. They control individual stars. And type 3 is galactic. They roam the galactic space lanes. So we'll have to understand the level of technology. Third, we'll have to understand whether or not they're potentially hostile or not, whether they can pose a threat to us. If they're type 2 or type 3, they could probably visit us, in which case we definitely have to wonder about what happens if we encounter them.
Wow, yeah, that's
And by the way, if they are very advanced and they have the potential of visiting us, we have to figure out what do they want. Many times in the movies, they want to take our Earth-like resources. But you see, there are plenty of planets out there that are uninhabited. They don't have to plunder us. They can have other planets to plunder if they feel like. So they're not going to want to do that. So what do they want? Well, we have to figure that out.
Wow, yeah.
One possibility is that, if you're in the forest and you talk to the squirrels and you talk to the deer, eventually you get bored with them because they don't talk back to you. And the same thing with these civilizations. If they're that advanced, they've been listening in on our conversations. And, we don't talk back to them in any intelligent way, so they lose interest. So for the most part, they'll probably leave us alone.
Do you think that could be happening right now where we have an intelligent life force communicating with us and we just don't know how to pick it up or respond?
Well, I think what is possible is that alien civilizations have discovered what I call laser porting. That is, shooting their consciousness on laser beams across the universe. This replaces flying saucers, replaces UFOs, no weightlessness problem, no accidents, no radiation, none of those problems. You just take your connectome, that is the neural pathways, put it on a laser beam, and shoot it through outer space. We could be next to a superhighway, a gigantic superhighway of beings laser putting themselves across the galaxy at the speed of light, and we are too stupid to even know of its existence. That's how primitive we are.
I mean, it could be even technology that we're not even able to imagine or grasp at all that could be going on, and we're completely not picking it up. You know.
Possibly, we use radio to communicate. Perhaps they've gone way past radio. Perhaps they're partly robotic. There are many scenarios whereby they don't do the kinds of technologies that we do, because we assume that they're only maybe 100 years more advanced than us. But let's say they're 1,000, 1,000,000 years more advanced than us. Then, of course, the way they communicate, what they want, is going to be completely different. And so we could be barking up the wrong tree.
Wow. And now I think of how we, as humans, interact with life forms that are less intelligent than us. And the thing that makes me nervous is that we're not always kind to intelligent or to life that is less intelligent than us. So I imagine that if there was an alien force that did come in contact with us and was more intelligent than us, that it might have malevolent intentions. Is that a right way to think, or am I kind of misled there?
Well, first of all, I don't think we should advertise our existence to alien life forms in outer space, because we don't know their intentions. They could be malevolent, as you pointed out. More than likely, they probably just don't care. For example, who's more dangerous to the deer, a hunter with a high-powered rifle or the developer? The high-powered rifled hunter is apparently more dangerous to deer, but really, the main danger is the developer, the guy with the blueprint. He's just going to pave you over and destroy your habitat and starve you guys to death. And he just doesn't care. The Martians in War of the Worlds were not evil. They did not hate us. We were just in the way. Just like in Hitchhiker's Guide to the Galaxy. The main problem is not the hunter. The main problem is that we're just in the way. And they simply don't care and just pave us over.
That's it's a lot of food for thought, and I'm always interested in what we're gonna find out next, and it's very uplifting to hear that you're saying that you think just in the next couple of years we're gonna find our twin out there, which can open up
within the next few years. I think within the century we'll probably receive interception of signals from intelligent life in outer space. So I think in this century there could be this historic moment where we make contact with intelligent life in the universe. Now, that doesn't mean that we can have a two-way conversation, because, of course, they could be hundreds of light years away.
Right.
So communication is impossible. But the fact that we can intercept messages from them, I think it'll happen in this century.
Wow.
But you think maybe we shouldn't be putting our signal out there and trying to connect with these intelligent life forms?
No, I think we should not, because we don't know their intentions. I think for the most part they're going to be benevolent because they're very advanced. But who knows? We could be in the way, or they could just be, they just don't care. So we have to be careful about advertising our existence. I don't think we should do that.
But we are, right?
Yeah, but I don't think we should add to it, in other words. We're already advertising our existence with radio. Television has Leave It to Beaver and I Love Lucy beaming into outer space.
Yeah.
I just don't think we should add to that.
I agree. Well, thanks again for being on our science segment this week.
My pleasure.
All of what you do has touched so many people in the world, and from all walks of life, and it's because of the way that you can explain the intricacies of science and what you're talking about, and it harkens back to that quote from Einstein. And speaking of cartoons, one of those people happens to be Bill Farmer, who happens to be the voice of Goofy, Mickey Mouse's friend in all of Disney's adaptations. He's one of your biggest fans and also a friend of our show, and he wanted to ask you a question.
Michio, I'm Bill Farmer. You might know me as the voice of Goofy. Gorge, someone's got to do it. And I'm a big fan. And I have a question. In the world we know, classical physics is the law of the land. In the subatomic world, quantum mechanics and a whole different set of rules takes over. Let's say I was shrinking. How far would I have to shrink until I would leave this world of classical physics and become trapped by the world of quantum mechanics? Is there like a state line where we move from one to the other?
Well, gee, that's a tough question. It used to be that people like Niels Bohr, the founder of one of the founders of the quantum theory, believed that there was a wall that separated the microscopic world, which is bizarre. Things can exist in multiple states simultaneously. Electrons can disappear, reappear, be in parallel states simultaneously. That bizarre world of the quantum is separated us by a wall, because we live in a microscopic world where you can only be one place at one time. Forget being multiple places at multiple times simultaneously. Well, now we know there is no wall. We think that Niels Bohr was wrong, that nanotechnology allows a smooth transition between quantum mechanical things and large things. So then, how do we then smoothly go from one world, the world where things can pop into existence out of nothing, and the world of today where a rock is a rock is a rock. A rock doesn't disappear. A rock doesn't turn into light. At the subatomic level, rocks can turn into light. That rock is uranium. That light is a nuclear bomb. And at the subatomic level, you can have all sorts of goofy things happening. And we now know there is no brick wall. It's continuous. Nanotechnology has given us the ability to smoothly manipulate individual atoms. And then the question is, well, if universes can exist in simultaneous forms, then is Elvis Presley still alive in a quantum parallel universe? And the answer could be, well, yes, Elvis Presley could still be alive, but why can't we talk to him? If that's subatomically possible, why can't we do it in real life, talk to Elvis Presley? Well, quantum mechanics says that everything is vibrating. When things vibrate in unison, that's called coherence, then they can interact with each other quantum mechanically. But after a while, they start to vibrate not in unison, and that's called incoherence, and that's the world of today. Our world today is incoherent. That's why we cannot talk to Elvis Presley. We're no longer vibrating at the same frequency. If we were vibrating at the same frequency of Elvis Presley, then yeah, we could talk to him, but we're not. We have decohered from him, and that's a separation. The longer you wait, the more the vibration and the waves separate, and that's why you can no longer communicate between two parallel universes. So it's a smooth continuation. It's not abrupt like we once thought.
Wow. Very cool. Speaking on interstellar space travel, the universe seems so vast and sometimes so unreachable. And actually, this was a second question that we got from Goofy, voice actor Bill Farmer. Again, like I said, he's one of your biggest fans.
The universe started as a single point of the Big Bang. It's been growing until now we see stars 13 billion light years distant. That means that light's been traveling for 13 billion years. Well, doesn't that mean that star that we're seeing that light from is now at least like 26 billion or even farther away? So how can the universe be only 13 point something billion years old?
Well, the farthest stars that we can observe are roughly 12 and a half billion light years from us. And that still means that the universe is older than the oldest stars that we can see in the universe. It used to be the opposite. Years ago, our measurements were not very precise, and the age of a star can be measured by calculating how fast it burns hydrogen. The age of stars was larger than the age of the universe. That was very embarrassing, because, of course, the universe has to be older than its stars. Now the numbers are in agreement. The numbers say that the oldest stars can be maybe 12 billion, maybe 12.5 billion years old, but the universe itself is over 13 billion years old. So the numbers agree now, which is very nice.
Wow, that's incredible.